Hi friends, good evening once again. This is Srinivas explaining the basic concepts of control systems, especially for the beginners, as well as it will help the lot of students who are basically uh, average, or otherwise it will be helpful for almost all the students. So in my past lecture I have explained what is the closed loop transfer function, okay, and what is the gain with the positive feedback for that closed loop control system. And today I am going to explain you about the transfer function of a closed loop control system with negative feedback, okay, that I am going to explain you. And I will explain you one small example. Basically the control system subject is a very interesting subject and is mostly problem oriented subject. Therefore we will go into the subject now. So again, just I will recap what we have seen in our last lecture. So in my last lecture I was explained, okay, open loop transfer function, and that is nothing but open loop control system as well as closed loop control system. Okay, so again just I will summarize for your better understanding that, okay, this is again I will recap. So in the last class we have seen the open loop control system. Open loop control system. Okay, this is what we have seen. So this we have seen already that the physical representation is like this is a system with gain G of S, and the input is R of S, and the output C of S. Okay, from this we have seen that the transfer function, the transfer function, this is TF, is nothing but the transfer function is nothing but the ratio of the the Laplace transform of the output to the input. This is the perfect definition. The transfer function at TF is equal to the ratio of the Laplace transformation of the output to the input, means to the Laplace transformation of the input. That means this implies transfer function is equal to, this means the meaning of this statement is that transfer function is equal to Laplace transformation of output is normally C of t, no, by Laplace transformation of your R of t. This is its meaning. And further this implies L of t means Laplace transformation of C of t. Okay, if you apply the Laplace transformation to the time domain signal, it converts into frequency domain signal, means the small c converted into capital C t is converted into s. This is what C of s now. C of s is nothing but the Laplace transformation of C of t. Laplace transformation of C of t is equal to C of s by, similarly, like this, Laplace transformation of R of t. Okay, this converts as capital R, and same t converts as R of s. Therefore, 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 you can write transfer function is nothing but what is this ratio? This is nothing but your g of s. This is nothing but your g of s. Therefore, you can write g of s is equal to nothing but your transfer function is equal to what is that? C of s by R of s. Okay, this is what. So you put in a bracket. Okay, so this is okay. In academic point of view, this definition is very important, because sometimes if you write directly the transfer function is equal to the ratio of output by input, if you define like that, it is wrong. You must mention that as it is what I have written here. You must mention the Laplace transformation of, that word is very important. Therefore, you must say that the ratio of the Laplace transformation of output to the Laplace transformation of the input. That Laplace transformation is very, very important. Okay, so in my subsequent lectures, I will explain why Laplace transformation is only will be used, or otherwise what are the various transformations. So in engineering field, as per the application required in solving the given problem very easily, so different transformations will be used. Basically, you have three types of famous transformations, like Fourier transformation, second Z transformation, third Laplace transformation. Basically, in your engineering field, or especially in your academic course of your graduation, you will come across these three types of famous transformations. One is Fourier transformation, second one is the Z transformation, third is the Laplace transformation. Okay, so Laplace transformation is very widely used, excellent tool you can say, or otherwise the transformation which will plays very important role in solving this excellent beautiful subject, control system. Therefore, only we are using Laplace transformation only in the control system subject. Okay, so therefore this much you remember right now, and in subsequent classes I will explain why, what are these transformations, and where the remaining transformations will be used, because otherwise we will go in different way of understanding the subject. Okay, so this is what the transfer function. And sometimes now coming, I am explaining you about the open loop control system. Now in open loop control system, so there is no feedback, as I have explained in last class. There is no feedback, therefore simply you have direct input, corresponding output, that's all. Therefore output, already I explained in last class, output is equal to your gain into input, that is C of s is equal to G of s into R of s. From there you need to bring a relation between these three, and finally you must write the ratio of output to the input. Obviously that ratio is nothing but G of s directly. Now this is what the transfer function, that's what I have explained here, G of s. Now this transfer function is called, this is called open loop, OLTF. I already explained in last lecture, OLTF, that is open loop transfer function, open loop transfer function. Okay, this is OLTF, open loop. Okay, I will explain it. What is OLTF? Okay, OLTF. OLTF is nothing but your open loop transfer function. Open loop transfer function. Remember this. Your OLTF is nothing but open loop transfer function. Now, coming to the closed loop system. Closed loop control system. So again, this is also same as what we have seen in our last lecture. So this is physically this is represented in this way, and already I have explained in last lecture that the basic representation is like this. Okay, so this is the part of output feedback, and this is given to the input side. Now this is what your input now. Okay, this is what your input, and this is what your output. Okay, this is what again gain. G of s is the forward gain, and this is what your h of s is the feedback gain. Okay, and always the input always must be positive only. The input is always positive only. In my last lecture, we have derived the relation output to the input. Here output is your C of s and input is your R of s. Okay, so in last class we have seen the relation between C of s to the R of s, or otherwise the ratio of C of s to the R of s we have seen with positive feedback. Now this today I am going to explain you the ratio of output to the input with negative feedback. Negative feedback means whatever the part of output you are feeding back at the input must be represented by minus sign. Remember that, minus sign. By simply seeing the diagram, you can able to say that whether it is positive feedback or otherwise negative feedback. If the sign is here, not required to consider this one. Input obviously always plus. This should not be minus. Input should not be minus. It never be minus. It always positive only. So this is the negative, means your feedback. You are feeding back the signal with the negative sign, means it is a negative feedback. Now the relation between C of s to the R of s. What is the relation? What is the ratio C of s by R of s? We have to find out. As I have explained in the last lecture, in the same way, so part of output is nothing but C of s only. This is the output. So part of output means C of s you are giving like this, means C of s you write. Part is nothing but you can identify that part as C of s only. C of s. This C of s is you are feeding through this feedback element. It is entering now. Okay, now you are considering the output here, means that is outside of this, in this direction you have to see, in this direction. Then this is the input, this is the gain. What is the output here? Gain into input. Therefore h of s into C of s, means okay, it is h of s into C of s. This is now the output where after feedback. Now this quantity will goes as feedback signal here. Obviously now the two signals are entering here. As I have explained, this portion, this you can mention as a dotted line or not required also. This is called summing point. Okay, this is called, this point I have explained in last lecture. This is called summing point, because summing point, that is called summing point. Why? Because it is a summer means addition or subtraction will be takes place here, means two signals are entering, so it will gives the resultant output here. It gives the resultant output here, means you will take, you have to consider the output of this, that is called, as I have explained you that last class, that is called error signal, and basically represented as EFS, error signal. So the output of the summer is nothing but error signal, normally E of t, and the Laplace transformation of E of t is nothing but E of S. That's why I have represented E of S. Now, as you have seen in our last class, in the same way you derive the expression. You write E of S expression. What is E of S? E of S is equal to what? E of S is equal to, that is, this is entering, this also entering, but with the negative sign, means the negative will come to this, means minus H of S, C of S, that is the product, that is the minus sign will come before this product, means this is plus, this is minus, means E of S is equal to, I can write like this, your R of S minus H of S, and then your C of S, so this is what your E of S, call it as equation number 1. Understood? This is E of S, because this is negative feedback, you are feeding the signal as negative, that's why R of S minus will come because of negative feedback. For example, if it is a positive feedback, then obviously here comes positive. Don't confuse, please, you follow very carefully, you definitely will enjoy the class. Okay, so based on this sign negative, that's why you will write here negative. If it is positive, then you will write positive, that's all. Okay, now I am considering the expression E of S as the equation number 1. That is first expression you need to remember, or you need to write in order to find out the transfer function of this closed loop control system. This is the, you have to write expression like this. Now the second expression, what is the second expression? Simply write the expression for C of S. C of S, what is C of S? So what is the C of S? C of S is straightforwardly output of G of S, means it is the output you are taking at here after G of S. Therefore for C of S, what is the gain into its input? Now here, what is the input to this gain? For this gain, what is the input? Not your R of t, don't confuse. R of t is the input, but now this input is the input to the summer only. This input is not directly to the input, its gain. Okay, R of t is the input only up to this summer only. After summer, because of the application of this feedback, your input added with some feedback element here. Your input added with some other element, means this much is added to their input. This is what we are using. This is your input, this is added, means okay, minus we have applied because of negative feedback. So from input, some portion of output with feedback we are subtracting. In negative feedback it will be subtracted, whereas in positive feedback it will be added. In later classes, no, I will explain you what is the advantage of negative feedback, what is the advantage of the positive feedback, what is the comparison. I will explain you in the subsequent classes. Okay, therefore now the input of G of S is not R of S, so the input to the G of S is your E of S. Remember that this is the input. What is G of S? E of S nothing but this quantity. You are seeing now, this is the quantity, this E of S is the input to the G of S. Therefore now the expression for C of S is equal to G of S into input, means G of S into E of S. Write the expression there, then it comes C of S is equal to, this implies I can write it as C of S, means second expression, C of S is equal to gain gain into your E of s. Is it not? Gain into E of s. This is your second expression. So for this, little bit simplification is furtherly required for this. I will simplify. I will simplify. Okay, I will simplify. Therefore, we will see. Okay. So this is, we have seen two expression. Now I will write again for your this thing, for your better understanding. This is E of s is equal to R of s minus H of s into C of s. Is it not? This is your first expression, and second is the C of s, means output expression. Nothing but what is this? Gain into E of s. E of s means error signal. These are the two expressions. Now you can do anything. Either you substitute equation 2 in equation 1, means wherever C of s is this much, no? So this C of s value means this much of value you can substitute here. Or otherwise you can write the total E of s value in the second expression here, which is you can apply in either of things. Now I will apply here. I will substitute equation 1. Okay, equation 1, substitute equation 1 in equation 2, means I will substitute this total E of s value is this much, no? This E of s value I will substitute here. Then I will have the expression for C of s. This implies C of s is equal to what is that? G of s into E of s, no? This E of s is nothing but this one you have to, means R of s minus H of s into C of s. Okay, this furtherly you can simplify. G of s into R of s, okay, minus G of s is multiplied with this, means G of s into H of s into C of s. This is what C of s is equal to. And next, this quantity, because here on left side you have C of s and on the right side you have two parameters. One is G of s into R of s. This is one quantity on the right side, as well as on the second, this is the second quantity in which you have C of s, no? So left side you have C of s, on the right side also in this parameter of C of s. Therefore this minus of this quantity you should bring to the left side, means this implies, then it becomes C of s. Obviously it will be here only, it is minus, no? If you bring this side it will becomes plus what is that? G of s H of s into C of s is equal to what will remain? G of s into R of s. Okay, and furtherly what we will write furtherly from this, no? Here C of s is there, here C of s is there. You take C of s as common, then so C of s, if you take common, here you will have 1 plus C of s is came outside, you will have G of s into H of s is equal to, it is G of s into R of s. Now what I should write? What is my target? To obtain the ratio of output to the input. What is output? C of s is your output. What is input? R of s, means this C of s by R of s you have to write, means C of s is here only, right side R of s you should bring to the left side, means C of s by R of s, means G of s will be on the right side only, bring this total part onto the right side, means how it becomes? how it becomes, it becomes like this. Means how it becomes, it is then your C of S by R of S is equal to, it becomes G of S by 1 plus G of S into H of S. This is the relation. This is what your transfer function. Put in a bracket. Okay, put in a box. This is what transfer function. Okay, what is transfer function? CLTF. This transfer function is called as CLTF, that is closed loop, that is called closed loop transfer function. Transfer function, closed loop transfer function with negative feedback. This is the closed loop transfer function with negative feedback. Whereas in my previous session we have seen that with positive feedback. Have you remembered that? I will write for your benefit. C of S by R of S is equal to, it is G of S by 1 minus G of S into H of S. I think you might have remembered. This is I will put in a box. Okay, so this is your transfer function. This is your transfer function with positive feedback. So if you remember these two, this is what with negative feedback, this is with negative feedback, this is with positive feedback. I mean positive feedback. This expression is with positive feedback. Okay, this expression is with positive feedback, whereas this expression is the negative feedback. What you observed? So if you give the positive feedback, no, if you give the positive feedback, so both are seems the similar. Both expressions are seems to similar. Okay, G of S by 1 plus G of S H of S. Here G of S by 1 minus, only the sign is different here. So with the negative feedback, in this denominator part, this is numerator, this is denominator, hai. So this is numerator, this is denominator. Therefore, so with the negative feedback, in the denominator you will get positive. With the positive feedback you will get the negative. That's all. That's all. Very easy. Therefore, these are the transfer functions called as closed loop transfer function. Closed loop transfer function. Okay. Now remember that one important thing I am going to explain you. That remember, here you are observing, no, 1 plus G of S into H of S. This denominator part in both the conditions, if you equate this equal to 0 in this particular expression, the denominator part 1 plus G of S into H of S equal to 0, that means I will explain you. That means 1 plus G of S into H of S is there, no, denominator part. If you equate this whole, this total equal to 0, then this expression is called characteristic equation. This is called characteristic equation. This is called characteristic equation. Means we have to equate that equal to 0. So sometimes this will be very useful in GATE examination, or even in IAS examination, Indian Engineering Service examination. Okay, even in your academic also. So with the negative feedback, the characteristic equation like this, whereas for the positive feedback, it simply for the this is for negative feedback. This is the characteristic equation for negative feedback control system. Negative feedback control system. Negative feedback control system. Okay, this is the characteristic equation you must remember. Whereas for the positive feedback control system, it is just 1 minus g of s into h of s equal to 0. That's all. This is called as characteristic equation. This is called characteristic equation of control system of closed loop. With positive feedback. Okay, so remember this also. These are the very important. These are the characteristic equation. Sometimes in examination they will give you the gain, open loop gain, and even the gain of feedback also. They will ask you find out the characteristic equation of this particular system. So I will explain you. Just I will explain you one simple example so that you will understand. For example, and one more thing also. For example, this is small brief example for you. This example, with this example, I will stop today's lecture. Small example, right? C of s, this is your R of s, this is positive, let us say negative. Okay, then they will give like this. Say for example, you write some directly. Sometimes they will ask yes, they will give the gain of the system as yes, and here this is the means g of s. You can write g of s is equal to s, whereas h of s is equal to, let us say, 1. Okay, so find out the CLTF. That's all. What is the CLTF? Closed loop transfer function for this circuit. This is the given block diagram representation of closed loop control system. You are asking find out CLTF. So if you observe here, this is the G of s, this is the H of s. So so feedback is fed with negative sign. Means what type of feedback it is? Negative feedback. So therefore solution, we know that for the negative feedback, control system, the CLTF is given as, means closed loop transfer function can be given as, what is the formula for the negative feedback? Okay, it is directly G of s by 1 plus G of s into H of s. Remember that if it is given negative, you just write plus only in denominator. That's all. If it is positive, you write here negative, that's all. It is negative, no, negative feedback, it comes like this. Now this is the simple expression CLTF. Now substitute all the given. What is the g of s value given? S only, s by 1 plus, what is g of s? Again s. What is h of s? It is 1. Therefore further simplify, s by 1 plus s, or otherwise, that's all. This is what your CLTF. See, that's all. Or otherwise you can write CLTF as, okay, CLTF as, this is s by 1 plus s or s plus 1. You can write anything. This is the closed loop transfer function. Now this is your closed loop transfer function. So sometimes in examination they may ask any type of question. Sometimes they will give open loop transfer function. What is open loop transfer function?